All right, so we're doing 10.1 lines and segments that intersect circles. We're going to do a little recap uh, just to kind of get down some of that vocab. I know that there were quite a few people that were out. Um, Big thing, overarching theme is circles. Okay, so circle, a set of points that's equidistant from a given center. Uh, the center here in this case is P, and we would write this as circle P. There are different parts of a circle, or different things that could go through a circle. First one is a radius. It's a segment whose endpoints are at the center, and then any point on a circle. That's probably the one that you're most familiar with. That in diameter. Diameter is a chord that contains the center of the circle. So what is a chord? A chord is a segment whose endpoints are on the circle. I'm going to show you. There's a picture at the bottom. I'll show you everything. Secant is a line that intersects the circle in 2 points. So with a chord, radius and diameter, technically, all of those are line segments. A secant is a line that intersects. So a secant will actually have a chord within it. And then a tangent is another line, but the difference between a secant and a tangent is a secant that contains a chord will go through the circle. The tangent will only touch at one point. So if you take a look at these pictures, okay, right over here is what we're talking about with the line segments. So chord, a diameter. Diameter, remember, it's a chord because it goes from one endpoint to another, but it goes through the center. And radius always goes from the center to the outside. The radius will always be the same length the entire way around your circle. Then you have over here the line, instead of line segments, of lines. So secant is a line. Notice there is a chord that it goes, technically there is a chord in every secant. And then the tangent is a tangent line. It's a line that touches at one point. We call it the point of tangency. We'll talk a little bit more about the tangent compared to the other ones because that is what we need to know the most. In this first example that we went over in class, we talked about just naming things. We named AC. And I'm just going to go over these in red. Went from an endpoint to the center, so that was a radius. AB then goes the whole way across and it goes through the center. So it's called, technically, yes, it's a chord, but it's a special type. It's called the diameter. DE, that one was supposed to be there. DE is what we call a tangent because it only touches. And then AE is a line, it goes through it, so it was called the secant. Okay, and then we talked about the different types of chords that you could have. If you take a look at those, I kind of made a basketball setting, but chords could be anywhere as long as they're inside and they're line segments. I think this is all just about as far as we got last time. Tangent circles, we talked about coplanar circles that intersect at one point. Concentric circles are coplanar circles that have a common center. And then we talked about a common tangent, a line or segment that is tangent to two coplanar circles. A lot of the discussion was about what are concentric circles compared to what tangent circles look like. The only thing I think that you guys really need to understand is what the common tangent is. And I'll kind of show you some examples there. So I kind of drew some different things here. And then how to kind of draw your tangent versus your concentric. The big thing with this is concentric have the same middle point, the same center. Tangent will not. Okay, so you don't really have to memorize any of that. It's about the tangent lines. So we went through example 2, and I'll pause here for a minute on tangent lines. Tell how many common tangents the circles have and draw them. So there are 2 types of tangent lines. One is called external, that lie on the outside. That means that you have a line that touches each circle one time at one point on each circle, and it lies on the outside. And then you have internal tangents, which means that they go in between the two circles. Obviously, if you look at example C, there's nothing internal because the circles actually overlap. But internal go in between, external go on the outside. A lot of work that you do with circles in this section is all about tangent. I'll give you another minute if you have anything that you're copying down. All right. Now let's go into a little bit more about tangents. And these are the two big things that, especially with algebra skills, that kind of help you. The first one is a tangent line to circle theorem. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint. So essentially what this is saying is for every tangent line, there will be a radius that makes a 90-degree angle. That is huge because you're going to see with some of these different types of problems, you'll be able to solve for your variable knowing just that this creates a 90-degree angle. The other thing that we have is the external tangents congruence theorem. So tangent segments from a common external point are congruent. So all this is telling us essentially is if we have a common point, that those two tangent segments there are congruent to each other. And because of the other one, I just want to show you this before you turn the page. Check this out. Because of this, we also know that this radius will create a 90-degree angle, and this radius will create a 90-degree angle as well. So take a look at this example here. I'm going to walk you through a couple different examples. I'm recording. Do you have a question? Can you give me like 5 minutes? Okay. Is ST tangent to circle P? Okay. So what we want to figure out is if this is tangent, then this creates a 90-degree angle. How we could determine whether this is tangent or not is by using Pythagorean theorem to prove that 12 squared plus 35 squared is equal to 37 squared. So we'd want to use Pythagorean theorem. Remember, a squared plus b squared equals c squared. To say 12 squared plus 35 squared, is that truly equal to 37 squared? If that's a yes, when we all said and done, if this is a yes, then that is totally tangent. If it's a no, then it is not, because that therefore we would not have a 90-degree angle. Let me grab a calculator. So 35 squared plus 12 squared gives me 1369. And 37 squared also gives me 1369. So this works. So ST is tangent to circle P. Questions at all? The next example, we're gonna go back into doing a little bit of FOIL method or double distribution. Okay, something that you've done in algebra before, but you haven't seen in a little while. I'll take you through. It says in the diagram, point B is a point of tangency. Find the radius of C. So if you notice here, radius is always the same length everywhere around the circle. So this is R and this is R. But if we want to know um, what the radius is, and it's a point of tangency, this makes a 90-degree angle. So we're going to have to use that a squared plus b squared equals c squared, but include the r. So a squared plus b squared equals c squared now becomes r squared plus 80 squared equals r plus 50 squared. Because this is the whole entire line. That's what gives us the r plus 50. I'm going to rewrite this out. R squared is going to stay. 80 squared is going to give us 6,400. And then I need to FOIL this. So foiling means that I write this twice, the r plus 50 twice, or double distribute, whichever one you prefer. And then I'm going to go through and I'm going to rewrite this. R times r is r squared. R times 50 is 50r. And then 50 times r is 50r. And then 50 times 50 is 2,500. It's equal to r squared plus 6,400. I'm going to combine my terms. R squared plus 6,400 equals r squared plus 100r plus 2,500. And then I want to start moving things so I can just get r. Now, if I subtract r squared from this side, those will cancel. And then if I subtract 2,500, I'm going to end up with 3,900 equals 100r. Yep. FOIL. So FOIL, kind of technically, how do you FOIL? FOIL actually stands for first, outside, inside, last. So say, for instance, you had r plus, let's do something like r plus 5 and r plus 5. You do first, so the first two here. So that would be r squared, because you have two of them, so it's square. Then you do outside, so it's the outside two. That'd be 5r. The inside two, so 5r. And then your last, so 25. There. Okay, and then that would be your FOIL. Going back through, then I'm going to divide this by 100, and I'll end up with 39 is equal to r. So my radius is going to be 39 feet. Do we need some practice on FOIL? Yeah, just kind of like as a refresher and stuff, kind of like I did on the side. I'll try and incorporate that in tomorrow. Then maybe we'll just do like half of a class of just practice. Last problem that I have for you here for this video is just about tangent. And remember, the one theorem said external tangent congruent theorem. This is probably the easiest one for you guys, I feel like. If you notice, these two tangent line segments are going to be congruent. So we can solve 3x plus 4 equals 28. So subtract 4 and you get 3x is equal to 24 and x is equal to 8.